So we're trying to figure out what happens as x approaches infinity, and we want to think about how quickly these functions are growing. So natural log x grows slow, okay, very slow, whereas x cubed is going to grow faster. So we have small over big, which means that this is going to approach 0. This one's harder to understand because x to the 100 grows insanely fast, and it definitely grows faster than e to the 0.01x at first. But the fact remains that this is an exponential function. So eventually this is going to start growing much faster than x to the 100. It's just going to take a long time. The problem says not to use L'Hopital's rule, but we can kind of think about that in justification. If we were to take this derivative 100 times, eventually that 100th derivative is now going to have an exponent of 1, and then the derivative after that is going to be constant, right? Whereas this derivative, e to the 0.01x, though it's going to be really small at first, it's always going to be exponential. So this has a higher order of magnitude, and even though it may be hard to come to terms with, this one is eventually going to be growing faster. And at infinity, this one's going to become way bigger than this one. So at infinity, this is going to approach 0 as well. Now this one's easier to see. Root x is definitely growing slower than just normal x. So this one also approaches 0. So all three of them approach 0 because in all three cases, the denominator eventually is going to be growing faster than the numerator.